So we've got the function f of x is equal to 2x to the third plus 5x squared minus 7, all of that to the 8th power, and we want to find the derivative of our function f with respect to x. Now the key here is to realize that this function can be viewed as a composition of two functions. How do we do that? Well, let me diagram it out. So let's say we want to start with, I'll do it down here so I have some space. So we're going to start with an x, and what's the first thing that we would do? If you were just trying to evaluate it, given some x, well, the first thing you would take 2 times that x to the third power plus 5 times that x squared and then minus 7. So what if we imagined a function here that just did that first part, that just evaluated x, just evaluated 2x to the third plus 5x squared minus 7 for your x. So let's call that the function u. And so whatever you input into that function u, you're going to get 2 times that input to the third power plus 5 times that input to the second power minus 7. And so when you do that, when you input with an x, what do you output? What do you output here? Well, you're going to output u of x, which is equal to 2x to the third power plus 5x squared minus 7. And I'll do it all in one color just so I don't have to keep changing colors. So 2x to the third power plus 5x squared minus 7. That is u of x. Now what's the next thing you're doing? You're not done evaluating f of x yet. You would then take that value and then input into another function. You would then take the 8th power of that value. So then we will take that and input it into another function that, let's call that function v. And that function, whatever input you give it, and I'm using these squares just to say whatever input goes into that function, you're going to take it to the 8th power. And so in this case, what do you get? What do you end up with? Well, you end up with v of u of x, or you could view this as v of 2x to the third plus 5x squared minus 7, or you could view this as 2x to the third plus 5x squared minus 7, all of that to the 8th power. And that's what f of x is. So as we just saw, f of x can be viewed as the composition of v and u. This is f of x. So if we write f of x being equal to v of u of x, then we see very clearly that the chain rule is very useful here. The chain rule tells us that f prime of x is going to be the derivative of v with respect to u. So it's going to be v prime of, not x, but v prime of u of x, the derivative of v with respect to u, times the derivative of u with respect to x. So u prime of x. So we know a few things already. So let me just write things down very clearly. So we know that u of x is equal to 2x to the third power plus 5x squared minus 7. What is u prime of x? Well, here we're just going to use some derivative properties in the power rule. 3 times 2 is 6x. 3 minus 1 is 2, 6x squared. 2 times 5 is 10. Take 1 off that exponent. It's going to be 10x to the first power, or just 10x. And the derivative of a constant is just 0, so we can just ignore that. So that's u prime of x. Now, we know that v, if we inputted an x into v, so v of x would be equal to x to the 8th power. V prime of x, well, we just use the power rule again. That's 8x to the 7th power. And so v prime of u of x, so if you were to input u of x into v prime, well, it's going to be equal to, 8 times u of x to the 7th power. Whatever you input into v prime, you're going to take it to the 7th power and multiply it by 8. So u of x, and that's the same thing. That is the same thing. This is equal to 8 times this entire expression. U of x is 2x to the third power, plus 5x squared minus 7. So there you have it. F prime of x, it is equal to this, which we just figured out. V prime of u of x is all of this business. So it's equal to 8 times 2x to the third plus 5x squared minus 7, all of that to the 7th power, times u prime of x. U prime of x we figured out is that. So times 6x squared plus 10x. Now, as you get more practice with the chain rule, you'll recognize this faster. And actually, you won't have to write all of this down. You'll be able to do a lot of it in your head. You'll say, okay, I'm going to take the derivative of the outside function, the blue function, you could say, with respect to what I have in the inside. So if I was taking the derivative of x to the 8th, it would be 8x to the 7th, if that's with respect to x. But if I'm taking the derivative of this with respect to the inside, well, where I had the x's before, I would just have this u of x. So it's going to be 8 times this to the 7th power, and I multiply that times the derivative of the inside, which is 6x squared plus 10x.